Okay, this is day 2 of lesson 3.3, which is our logarithm properties. As a refresher, we have 3 big properties we're focused on: product property, quotient property, and power property. Okay, so we did a couple examples kind of using these properties, and we left off here with number 3. So it says, find the exact value of the logarithmic expression without using a calculator. So if I look here, this is log base 5. Now, unfortunately, there's no way to write 250 with a base of 5. But we can kind of break it up a little bit. And this is kind of how I think of this problem. There's a couple different ways you can do it. But 250 is obviously 25 times 10. And I'm like, okay, 25 I could write as 5 squared with a base of 5, and 10 is 5 times 2. So it's pretty close to being able to write this as a base of 5. I could write it, this number, almost like it's prime factorization. I remember doing that kind of like in elementary school. I could rewrite 250 as 2 times 5 cubed. And again, my reason for doing this is I'm kind of trying to see if I could write it with the base of 5, since that's the base of this log. Okay. All right, so log properties now come into play. I could do the log of the numerator and the log of the denominator. Now think exponent properties. If you're dividing, you're really doing what with the exponents? Subtracting. Yep, subtracting. This is asking you 5 to what power gives you 1, which is what? Yep, 0. So that evaluates to 0. And then here I can break this up because I see I have a product. So anytime you're breaking it up and we have subtraction out here, let's use these brackets. I could rewrite this as log base 5 of 2, that's 1 factor. Log base 5 of 5 cubed. Here's kind of that product property. And I would add those separate logs. Okay. So obviously you don't really have to worry about that 0. But I see I have negative log base 5 of 2. That's asking me 5 to what power gives me 2. That's not something we can evaluate in our head or without a calculator. But here, 2 ways you could think of this. This asks you 5 to what power is 5 cubed, or you have that property that if you have the matching bases, they are inverse operations, they undo each other. I just have minus 3 here. And that's technically the exact value. And this is really a number. We just can't evaluate what that is without a calculator. So that's as far as we can go. That was kind of fun. I like that problem. Uses a lot of different properties: quotient property, product property, inverse property, or like matching bases, and a couple that you can evaluate in your head, like 5 to what power is 1. Okay. The next set of problems also incorporates those log properties. So they're telling you approximately what these logarithms are equal to. So this is asking, 2 to what power gives you 3. So it's about 1.585. Okay. Type this in your calculator, get the same thing. And they're telling you log base 2 of 7 is about 2.808. So using that information, how could we evaluate these other logs, such as log base 2 of 3/7, log base 2 of 21, and we could use actually like those log properties. This one's the most obvious because I obviously have a quotient, right? So log properties, I could take the log of my numerator and the log of my denominator and do one operation with these, subtract, right? And we know what this is. Log base 2 of 3 is this. Approximately, obviously. And we know what this is. Approximately. Ooh, stick with my color coordination here. So we can use that to figure out 2 to what power? Give me 3/7 approximately. Subtract those. I got that. So you're basically going to ask yourself on these problems, like, since we're given what log base 2 of 3 is and what log base 2 of 7 is, how could I maybe rewrite whatever I'm trying to evaluate in terms of 3 or 7? And then we can use these properties. So how could I rewrite 21 using 3 and 7? 3 times 7, right? And then we can use product property. Okay, I can break this up. That's the same as log base 2 of 3, log base 2 of 7. Each factor gets their own log, and because it's a product, we would add these. We know this. It's 1.585. We know this is 2.807. So to figure out log base 2 of 21, and let's see if this makes sense in our head, 4.392. Does that make sense that 2 to that power would give us around 21? Well, what's 2 to the 4? 16. What's 2 to the 5th? 32. So yeah, that makes sense. That's somewhere in between 4 and 5. Because 21 is between 16 and 32. Okay. Couple ways you can obviously do 49. You can do 7 times 7 and do the product rule again, but for sake of mixing up our rules, let's do 49 as 7 squared. And let's use the power property, where my exponent would come out in front. This is the same as 2 times log base 2 of 7. Which just makes sense. If you were to do 7 times 7, you just add that twice, and that's the same as doubling it. Why this works. So I got about 5.614. Okay, so we just said we know that 2 to the 5th is 32. Do you guys know what 2 to the 6th would be? 64. So obviously 49 is in between 32 and 64, so that makes sense. All right, what about 27? 3 to the third. You guys are geniuses. Definitely would rather write that one as an exponent than do 3 times 3 times 3. Bring the power out in front. Think power to a power, we multiply. This one is that 1.585. So that's about 4.755. And if I compare this, because this is log base 2 of 27, this is log base 2 of 21, if I compare it to my answer, it makes sense that that power would be a little bit bigger. Okay, than what we got here. 2 to what power give me 27? Obviously a little bit bigger than 2 to what power give me 21. Logarithms evaluate exponents, they're numbers. All right, I have one for you guys to try on your own. Think of it as like a little game against yourself. Try these ones. And you can keep checking your score out of 4. It'll be fun. This time you're getting log base 6 of 5 and log base 6 of 8. Okay, I'll start to kind of write some answers up here while you're still working. Okay. Check your answers. Okay, not bad, right? Starting to kind of see the properties a little bit. How many of you were 4 for 4 on that fun game? All right. Okay, let's step it up a notch then. Let's do something a little more challenging. Okay, these are fun. We are going to use our logarithmic properties kind of 2 ways. So the first set of problems we're going to do are expanding. What does the word expand mean? Make bigger, right? So we're going to use our log properties this way where we have like a condensed logarithmic expression and we're going to try to expand it as far as we can. Okay? Then if you look down at your notes, you'll see we'll go backwards where we have a big long log expression. So we'll have like this side, this right-hand side of our properties, and we're going to condense it and put them all back into one big happy log family and use our properties like this way. Okay, from right side to left side to right side. And I mentioned we use them both ways. Okay, so basically anytime you have like a lot of variables too, you want each variable to have its own log when you're expanding. So here, start with something simple. I have technically a product, right? I have 5 times x cubed times y. I have 3 factors, 3 things that are being multiplied. So I can expand this using my product property that each factor gets its own separate log, in this case log base 4, and since I have a product, what operation would I do in between these logs? Add, yep. All right, so we already definitely like expanded this, right? It's way bigger. The last thing you got to do, so I always take care of products and quotients kind of like first. See if there's any exponents where we can use our power property. And I mean, obviously 5 doesn't have a power. You should check if you can evaluate this in your head. 4 to what power gives you 5? That's not something we can do in our head, so we just leave it for an exact answer. But here I have a power, and I can bring that down, and that's technically still expanding it. And then my y, I don't have a power. So my final answer here, bring it out in front, multiply it. The most expanded we can do here would be this expression, where each kind of like term has its own logarithm, and then you bring down any powers. And there's only 3 properties, so you take care of product and quotients kind of first, powers last. Isn't that fun? Okay, let's do another one. Remember, all these same properties apply for natural logs, log-based anything. So here I see I have a quotient. All right, so right away I'm going to split up my numerator and my denominator by giving them their own separate logs. Since I have a quotient, what operation would I do here with the logs? Subtraction. Bingo. Okay. Now here with the radical, I technically have a power, right? This is the same as 3x minus 5 to what power? 1/2. Good. Yep, so you got to recognize that. Oh, gosh. Natural log of 7, that's definitely not something I can do in my head. E to what power gives me 7? No idea. And then I recognize, okay, power property, I can bring that power on front and multiply it. Now this is not technically a product. You might think, oh, I have 3 times x here, but I have 3x and I have minus 5, and you can't split that up any further. Okay, so remember, that was kind of like a little bit of like that caution property I told you. Like some people think like with adding and subtracting, oh, we can like split it up into 2 separate logs. We can't do that, only if we have a product there. So this is actually the most expanded we could get for number 2. Get in the habit of writing your log expressions with parentheses if you have more than one term like this. Okay, I'm okay. You don't have to do like this on your arguments if you just have a number. You can if you want to. But if you do this, I don't know if that says you're taking the natural log of 3x and then subtracting 5, or if you're taking the natural log of 3x minus 5. So I'll be really picky about this in logarithms, and next chapter when we get to trig, you need to be like really specific with what your argument is or what you're actually taking the natural log of. So use the symbols, use the parentheses. Like I said, here it doesn't matter because you only have one thing, but if you want to, you could write it like that.
Have your attention for a couple schedule adjustments.
Yeah, sure, Mr. Tolson.
Students in grades 6 through 7, they'll be released from their lunch at 42, and their 5th hour classes will begin at 45. So 6th and 7th grade 5th hour classes will begin at 45. After that point, everything else is on schedule for normal bells the rest of the day. Again, all students will report to 4th period classes during RTI today, where 4th period attendance will be taken. Thank you.
Good deal. All right, let's try a couple more.
Yes.
We're going to get this a little more challenging, but not bad. There's only 3 properties. Exponent properties, there's like 8 or 9 exponent properties. With logs, there's only 3. Okay, so right away I see a quotient. So I'm just going to split up. Careful here. I'm going to do this in 2 steps for a reason. I'm going to split up the numerator and denominator. There's my quotient property by subtracting. If you notice you have a product here in your denominator, that's good. We have to split that up as well. So when I go to do that, because I'm subtracting this log, you need to add in parentheses. And then we can go ahead and split this up. Each factor gets its own log, and since that's a product, I would add them. But you're still subtracting that whole thing because both of those terms are in your denominator, okay? If you wanted to bring the power down in this first one, you could. I usually just wait till the last step to bring all the powers down, but you can if you want to. It doesn't matter. Okay. So then I see, all right, I have a bunch of powers here that can come out in front. That can come out in front. That can come out in front. I'm gonna kind of simultaneously also like distribute that negative or subtract both kind of logs here. So I would have 2 log base 2 of x minus 4. Oops, I'm forgetting to write base 2 on these logs. I don't know. I meant 2. I meant 2. I honestly don't know.
Is that another mistake?
Nope. That was to make sure you were paying attention. I hate when teachers do that. I'm so sorry. I'll never say that again. It's so annoying when people say it. All right. Log
It's like 3.
base 2y minus.
Wouldn't it be plus?
Nope.
No, that'd be minus.
It would be minus
Alright, you're wrong, Connor.
log
Plus.
base 2 of z. Because we're subtracting both of these. That's why we needed to add in the brackets. And that's a common mistake is people will forget. Like they'll get this far and then they'll split up their product and they'll do plus log base 2 of z cubed. So that's why I put it in red to catch your eye. You need to
Make sure we're paying attention.
yes.
Stop favorite.
Okay. I don't know which way I look better, expanding or condensing. I don't know. I'll let you guys decide once we do both. Oofta. One more. First, I kind of see this as I have a product here, right? I have x to the 5th times that nasty kind of radical. So let's go ahead and just split that up with our product property. Okay, that'd be your first step. Split that up, product property. Again, you could bring down the 5 in the first log if you wanted to, but I'm just going to wait and do all my powers last. I need to recognize here, anytime you have radicals, rewrite that as a power. That'd be to the power of what, folks? 1/3. Good. Okay. Now I can bring that power down. We can do it here too if you'd like. 5 natural log of x plus 1/3 natural log of y over z squared. Okay, now we're not done. If you look in this log, I still got a lot going on here. I still have a quotient and I still have a power. So this log needs some work. Okay. So, again, since I have this 1/3, it's kind of almost like the negative. Since I have 1/3 times this whole log, I'm going to add in parentheses. When I go to split up this log, so the natural log of y, the natural log of z squared, what operation goes between those two? Minus to do the quotient. Good. All right. Then I see a power with the z. I want to bring that down just to the z. And then the only other thing I'd maybe do to simplify this is go ahead and distribute that 1/3 then.
Especially on 1/3. Isn't that supposed to be 2?
Good job, you guys.
Making sure we're
You're on the
paying
ball. Yes, you're right. It's 2.
Don't you have the answer to?
Yeah, I do. I don't really look at it. I more hold it here for confidence, like in case I get stuck or in case I like. I'm not very good at like my mental math like skills. So all right, I know that's not a great characteristic of mine, but I am aware of my faults, which is the first step to improvement. Okay, there we go. Woo! Isn't that fun?
No. That's what I got from the
Sure.
I like these.
What if we're able to do it without showing steps? Will you mark wrong?
Yeah, I did it on the quiz. Don't try.
I mean, I need to see.
Brave soul.
I need to see enough.
Hold
I-
each one.
Yeah.
I went from that straight to that.
Yeah, if you can like go from Like if you can go from here to here, that's fine. You know, without having to break up the quotient and then the product. Like if you can go from there to there, you're like, all right, I have a quotient and a product. Just remember to add in your parentheses.
If I go from that to the inside.
No.
But I did.
That's it, but no.
You're
Okay.
hating on mental math. I don't like it.
Now we're gonna go the other way, and then we'll take a vote and see which one's your favorite.
Neither.
The expanding way.
All
So
of
now
these
we're
are
just gonna
all-
like go backwards. We're gonna put all the powers back and just try to condense it into one big happy log family.
I agree with Jackson.
All right, so
Yeah.
when we were expanding, our last step was to always bring the powers down, right? So our first step in condensing is to put the powers back. So if you see a number in front of these, let's put those back as powers. It's like we're picking up our stuff we drug out. Okay, putting them back. So we have log base 2 of x to the power of 5 plus log base 2 of x to the power of 7 minus log base 2 of y to the 4th. Okay. Again, a lot of you could probably do the next thing in one step, but just for sake of showing it in your notes here. Here we can condense these to one log. And since I'm adding these, what would I do with the x to the 5th and the x to the 7th? Multiply them, yep. All right, now I have it condensed down to 2. So finally, we can do this in one step, condense it down to 1. So obviously x to the 5th times x to the 7th, add the powers, we have x to the 12th. And since I'm subtracting that log base 2 by the 4th, I would divide. And that would be my final answer. You should check if there's simplifying you can do, such as x to the 5th times x to the 7th. If I ended up having like x to the 12th over x squared, I should simplify that to x to the 10th. Okay, so if there is simplifying you can do, you should do that. All right, let's try another one. All right, I see a 1/2 in front, put that back as a power. I see a 3 in front, put that back in the power. I'm gonna right away, instead of writing it as the natural log of x to the 1, well, I'll show this because we're doing notes. You can, if you want to write it as a square root of x right away, that's fine. Here I have x plus 1, that whole quantity is being cubed. Okay, so x to the 1/2 power is the same as the square root of x. Do not tell me that x plus 1 cubed is x cubed plus 1.
Yeah.
You can't distribute exponents. No, just leave it like this. You don't have to multiply it out. That's x plus 1 times itself 3 times. The kitten thing. All right. Now I can condense this to one log. What operation would I do with this guy and this guy? Multiplication. Good. So we just write this as the square root of x times x plus 1 cubed.
Poor kittens.
You know you're done with condensing if you just have one log. You have more than one log written in your condensed answer that's not fully condensed.
Math.
Ooh. This is fun.
Hashtag, do you guys do that? Hashtag vent.
Yeah.
You should try it, it's cool.
Yeah.
That's like a good
Hashtag math.
Hashtag. All right, couple more. Number 4, look at that one, it looks so fun. All right, sorry, let's not get carried away. Oh, number 2, that's a good one, number 3. All right, here we can put that back as a power.
Okay, right there.
Minus.
Pretty sure. I see.
Okay. I can condense this to one log by doing what with these two guys? Division, right? Division. So I have x plus 2 squared, since that's like my positive log that goes in the numerator, divided by x squared minus 4. Now I just said if you can simplify inside, you should. And the bottom factors, difference in squares. And I have two factors of x plus 2 in my numerator. So we have to catch, hey, we could get rid of one factor on each.
Nice one.
Whoa, I like it. If this were a function, yeah.
Good job, Swadek.
Nice.
Freaking nerd.
I like it.
What a nerd.
Can I cancel these x's?
No.
No, that would be killing a kitten, right? That's what the killing the cat thing is. Okay, do you guys want to try this one?
No.
Yes.
Yeah, try it.
Oh, I didn't.
Give it a whirl. It's our last one. Give it a
Already
try.
almost done with the cake. You're fine.
I'll give you
I
like a
probably got it wrong.
1 minute head start, and then I'll start writing mine.
This is
There's a couple ways you could actually tackle this one. I would condense this first before you distribute the 1/2.
What?
I would condense first before you distribute the 1/2.
I did it at the same time.
Oh, sheesh.
Bam.
Don't know like that, right? But it's like
You got
brackets
the-
and parentheses.
Yeah, there's lots of brackets and parentheses here. This
We were wrong.
is the product of these two logs.
Oh, why did I think of that?
That's what I say. I would condense first.
I am condensing. It says it in the instructions.
Not fighting on
Said it in
the.
Let me erase this.
Because this whole thing is being raised to the power of 1/2. So if you can condense it first, and
Yeah.
then,
I was trying.
Uh,
I couldn't figure that
I swear if we end up getting the right answer anyway.
and then put the power. So instead of writing it as the power of 1/2, I'm just going to square root it. Right? Because I did the same as the power of this whole thing.
I think it was being read in. And I erased it all. So
I was going to say, there's more than one way you can get to this answer. Okay, we're almost done. We have 2 logs. And now I can multiply those. So you'll more commonly obviously see like x to the 6th written in front of the radicals. Did you get this?
Okay.
I took canceled out the square one and then multiplied it on the outside of the square.
So long.
I'm trying to think if you could do that. I guess you could.
And
You
that's
don't really need to.
It's like
No,
that's
no,
what we did.
unnecessary.
Yeah, unnecessary simplifying.
It's-
That's about as tough as they get. So,
Okay.
wow, perfect timing. Only a minute to spare. Okay, I'm gonna stop the video.
Better than last time.
He goes too well.
No.
Why are you guys packing up? You have 2 seconds.